First, the greatest hazard to vitally needed food production. These dry, withered fields and empty irrigation ditches lie on the eastern side of the Continental Divide in northern Colorado, in one of the greatest food-producing areas in the western region, where winter snow and summer rainfalls are uncertain and inadequate for maximum land yield, thus reducing the food production of the region to an alarmingly low level. Just across the towering ridge of granite on the western slope of the Continental Divide is a vast mountainous region where snowfall is heavy and there is less thirsty land to be irrigated. Here, deep snows falling in the winter lie on the slopes during most of the summer months, slowly melting. This is an area of high peaks and jagged crags, remote and almost inaccessible. Water from the melting snow runs in tiny rivulets into many high lakes, which feed the clear, cold mountain streams that brawl and tumble through canyon, gorge, and valley, ever downward to the lower country. Many of these streams find their way to Grand Lake, a glacier-made bowl of clear, sparkling water, which the Indians called Giant's Washbowl. Here in this region, at an altitude of over 8,000 feet, is a water supply which for generations farmers and engineers have dreamed of tapping to irrigate the thirsty fields on the eastern side of the Rocky Mountains. Finally, the United States Bureau of Reclamation is bringing to realization the dream of many years. A series of dams to retain a part of the Colorado River water and keep the level of Grand Lake constant were planned. A tunnel 13 miles long through the Continental Divide to carry the water eastward to the plains is fast becoming a reality. From Grand Lake, over 300,000 acre-feet of water will flow annually through the 10-foot bore, which is being driven from both sides of the divide. These are the surface buildings which house compressors, ventilation fans, and maintenance equipment at the west portal. John R. Austin, veteran of high-speed tunneling throughout the West, is directing the tunnel's advance from the west. The tunnel is being driven on a 24-hour basis. Men are transported to and from the heading 3 times daily in specially built safety man cars. Drilling is the first operation in the tunneling cycle. 5 automatic power feed drills mounted on a 30-foot long 7-ton drill carriage, or jumbo, drill 38 to 46 holes 9 feet deep into the hard granite face of the bore. These drills are powered by compressed air delivered to the heading in a 6-inch line from the huge compressors at the tunnel portal. Water is forced through the hollow drill steel to wash the rock cuttings from the hole. Detachable bits dulled through contact with the hard rock are quickly replaced by sharp bits at the rear of the jumbo by nippers. A steel carrying compartment is an integral part of the jumbo. Under the jumbo deck, miner and chuck tender crouch over one of the lifter machines. Because the tunnel slopes downward from the west, these men work in water which must be pumped from the bore constantly. While the wing machines above drill the upper holes of the round, the drills under the deck are drilling the lower, or lifter holes, which serve to throw the blasted rock away from the face. Drilling time for the round averages 60 minutes. The rock here, almost a mile beneath the crest of the Continental Divide and 4 miles from the tunnel portal, is exceptionally hard, being a Precambrian granite and schist formation. Drilling completed, the drills on their retractable columns and arms have been folded to the center of the jumbo, allowing ample room for loading 400 pounds of 60% dynamite into the 46 9-foot deep holes. Electric detonators of 1 to 10 delay serve to fire the round. The primer, a stick of dynamite into which one of the detonators has been inserted, is placed in the bottom of each hole, which is then tamped full of dynamite with wooden loading sticks. 15 minutes are required to load and wire the round in this $10 million tunnel, the longest ever driven in America from only 2 headings. When the blast is fired, the cut holes in the center will go first, tearing a huge block of rock from the center of the face. Then breast and reliever, and finally the lifter shots will be fired by the delayed detonators, loosening the muck pile for loading into the cars. When wiring of the round has been completed, it is checked by the shifter in charge of the heading crew. Then men and equipment are moved back to the shooting switch, 1,000 feet from the heading, where the round is fired electrically. Giant blowers exhaust the powder smoke and gases from the heading within 5 minutes after blasting, allowing the crew to return immediately to begin mucking out 100 tons of rock torn from the tunnel face. Only 1 hour is required for completely mucking out the round with this IMCO Model 21 loader, which is operated by one man. The rock is dumped into cars of 90 cubic foot or 5-ton capacity, which are attached to the loader with safety-type couplings that allow the car to follow the loading machine. As each car is filled, it is pulled to one side of a California switch. From the opposite side of the switch, an empty car is pushed to the heading by an electric locomotive, then coupled to the loader. By this ingenious arrangement and the rapid operation of the loader, a car is filled and coupled to the train every 4 to 5 minutes. The loader is powered by compressed air, delivered to the tunnel heading in a 6-inch pipeline and attached to the loader by a hose. The unbroken rhythm of the bucket in the hands of an experienced operator reduces the actual loading time of each car to about 2 minutes. IMCO loaders working on both ends of the tunnel reduce the distance between the east and west headings with every swing of their buckets, materially reducing the time required to complete the tunnel through which water will flow to eastern farmlands, generating in a series of turbine stations over 150,000 horsepower of electrical energy, thus serving 2 vital needs. Rolling from the portal at a speed of 20 miles per hour, the appearance of the first muck train signals the completion of the round and the beginning of another cycle of drilling, blasting, and mucking. On the way to the dump, several hundred yards from the tunnel portal, a powerful diesel locomotive pulls the train up the grade, skirting beautiful Grand Lake. In this section of the Rocky Mountain National Park, the mighty Colorado River is born. Detachable arms placed on one side of each car run over a steel ramp, forcing instant discharge of the muck through the car's opening side. Every ton of rock sliding down the steep sides of the dump brings closer to the eastern farmlands needed water from the western slope. The east portal of the 13-mile tunnel through which the water will flow is just 5 miles southwest of the world-famous resort town of Estes Park, Colorado, on the eastern boundary of Rocky Mountain National Park. None of the natural beauty of the park will be marred by the thousands of tons of rock which are excavated at each end of the bore. These huge dumps will be landscaped to blend with their surroundings. Thousands of tons of steel I-beams stockpiled at each end of the tunnel are formed into horseshoe supports, then installed in the bore to hold those parts of the tunnel which require support. Millions of feet of lumber are used in ties for the railroad, for wedges, blocking, and timber support, which is installed above the huge steel rings. With the coming of western slope water flowing through the tunnel, irrigation canals on the eastern plains will run full during the entire growing season. The water supply will be stabilized by the Colorado Big Thompson project. Increased food production will be symbolized by prosperous farms reflecting the abundance of the green fields. The yield of corn will reach a high comparable with the best producing years the region has ever enjoyed. Seed vegetables in greater quantities will be harvested for constantly expanding markets. Staple and fresh food production will be doubled over previous years when irrigation was inadequate. Because there will be no fluctuation in the water supply, average annual food production will reach new high levels. Dominant in the march of products from northern Colorado fields is alfalfa hay, important in the feeding of livestock. Western slope water will bring the yield of this product up to as much as 5 tons per acre, resulting in a substantial increase in meat production. Over 20% of the nation's lamb supply is fattened in the northern Colorado area, a fact indicative of the importance of livestock feeding in this region. Modern feeding lots are a material part of many of the 8,000 farms which will be benefited by increased irrigation when water begins to flow through the Alva B Adams Tunnel from the western slope. Large numbers of cattle are also fed in commercial feeding lots as well as in individual feedlots owned by the farmers. Most of these fat cattle are shipped to Denver, which ranks among the largest in the nation's packing industry. Many dairy farms dot this major food-producing area. Milk, butter, and cheese are produced, processed, and packed within its borders, adding to the total food production. In the production of potatoes, one of the most important staple foods, northern Colorado leads the West in quantity as well as quality. Additional irrigation facilities will raise the total yield from approximately 90 bushels per acre in years when water is critically short to several hundred bushels per acre. Supplemental irrigation, constant in its source, will make every year's crop uniform in maximum production, all other things being equal. When sacked and ready for shipping, these potatoes will find their way to the major food consumption centers of the nation. From oceans of green sugar beets, northern Colorado produces over 1 million 100-pound sacks of sugar each year. 13 great sugar factories located at strategic points throughout the region have a total capacity of processing the yield from 200,000 acres of beets. In addition to the sugar, which is famous throughout the land, the beet tops play an essential part in the feeding of cattle and sheep. This project, when completed, will increase the average water supply by 40% through the use of the 13-mile tunnel and will raise the yearly production of sugar beets by as much as 50%. During beet harvest time, many thousands of tons of sugar beets are pulled, topped, and loaded for shipment by truck and train to the nearest sugar factory. Huge stockpiles of beets are formed at loading points, then at the sugar plants. From these, they are conveyed inside the plants, thoroughly washed and cleaned, and the sugar content is extracted, leaving only the pulp. But this is not wasted. It also is utilized in the rounding out of the stock feeding program. New types of labor-saving machinery promise to make this valuable crop even more prominent in the food production program. Hand labor has been its most serious drawback, but the sugar beet is an important item in the crop rotation plan, along with its other uses. Canning of fresh vegetables, sweet corn, peas, and tomatoes is another industry of northern Colorado that will benefit from the Alva B Adams Tunnel. Production increases may reach a total of 50%. Tapping the great snow shed that is the western slope of the Continental Divide will fill the canals and irrigation will be dependable. More than 1,000 square miles of rich, productive land, already equipped with canals, will reflect the advantages of perfect irrigation in the tremendously increased production so vitally needed in the ever-expanding food program which is reaching global proportions. Colorado, at the top of the greatest nation in the world, will share in this responsibility, supplying food from abundant green fields.